Next chapter, Electrochemistry-I. Okay. Electrochemistry-I. Okay, here. So let's see some basics of this electrochemistry. So what is the electrochemical cell and all? Okay. So electrochemical cell is a vessel. What it is here? Electrochemical cell is nothing but okay. It's a vessel. Okay. It's a vessel consists of two electrodes and electrolytes. Two electrodes. So what it contains? Mainly it contains electrodes. Okay, two electrodes. Electrochemical cell contains electrodes. Okay, and electrolytes. And electrolytes. Okay, electrolytes. Here, electrolyte. What is electrolyte here? What is electrode and what is electrolyte? Okay, so electrolyte is a substance. Okay, electrolyte is a substance which contains the electricity. Okay, in aqueous solution or in molten state. Okay, so what is the electrolyte? Electrolyte is a substance. Is a substance which conduct electricity. Okay, which conduct electricity. Okay, in where it conduct electricity, especially in aqueous solutions or in molten state, it conducts the electricity is called as electrolyte. The electrolyte, it is a substance which conduct the electricity in aqueous state, or in aqueous solution, in aqueous solution or in molten state or molten state. Okay, here the electricity is conducted in a electrolyte. How the electricity will be produced here? Electricity here, the electricity conducted in electrolyte. The electricity conducted in electrolyte. How this electricity is conducted by movement of ions, is it or not? Is so by the movement of ions, electricity is generated. Okay, so the electricity conducted in electrolyte by the movement of ions. By the movement of ions. By the movement of ions. So first we need electrochemical cell. So what is electrochemical cell? So this is a vessel, okay, which contains electrodes and electrolytes. Okay, so electrolyte is a substance which conduct the electricity in aqueous solution. Aqueous solutions are in molten state. So how this electricity is produced? By the movement of ions, electricity is passed through from one place to another place. Is it or not? Okay. So here the electricity conducted in electrolyte by the movement of ions. Here, okay, this is about this one. So next, electrode. Next, coming to electrode. Electrodes are of two types. Okay, electrodes are of two types. What are those? anode and cathode. Okay, these are of two types. One is anode and another one is cathode. Okay, so in this anode, which process takes place in anode? Anode. So in anode, oxidation takes place. Okay, oxidation takes place. Anode where oxidation takes place means here oxidation takes place. Loss of electrons takes place in this at this anode. Okay, so anode means what here? It lost electrons. If it lost the electrons, then process is called as oxidation. That process occurs at anode. And what about cathode? So cathode, so here reduction takes place. Reduction takes place means gaining of electrons. Okay, gaining of electrons takes place at a cathode. Okay, loss of electrons takes place at a anode. Okay, so reduction takes place at this cathode. Okay, so for the electricity means electrochemistry here. So we want first electrochemical cell, okay, and electrodes and electrolytes. So electrolytes, this is a substance which so this conducts the electricity, mainly electricity in aqueous solution or in molten state, and electrodes. Say if you so next electrodes are of two types. One is anode and second one is cathode. Okay, so at the anode oxidation takes place. Okay, and cathode reduction takes place. Okay, so next here there are two types of electrochemical cells are there. Two types of there are two types of electrochemical cells. Electrochemical cells. Okay, so let's see what are those. First one is electrolytic cell. Electrolytic cell. What is first one? Electrolytic cell. Here, electrical energy is converted into chemical energy is called as electrolytic cell. In this, which process occurs? Electrical energy is converted into chemical energy is called as electricity. Okay, electrical here electrical energy is converted into chemical energy. Chemical energy is energy in electrolytic cells. What happened in electrolytic cell? In electrolytic cell, the electrical energy which is converted into chemical energy. Okay, so energy in electrolytic cell. Okay, example electrolytic purification of copper or aluminum. Okay, copper or aluminum. Okay, next example, recharge of secondary cells. Okay, second one, galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Galvanic or voltaic cell. Here, reverse. Chemical energy is converted into electrical energy in this galvanic cell. Okay. So in electrolytic cell, electrical energy is converted into chemical energy. But in this case, galvanic cell, what happened here? Chemical energy is converted into chemical energy is converted into electrical energy. Okay. Okay. Here, what happened here? Chemical energy is converted into electrical energy. Electrical energy. And vice versa in electrolytic cells. Okay. Electrolytic cells. Okay. Example, dry cell or lead acid batteries. Lead acid batteries. Lead acid batteries. Okay. Lead acid batteries. Okay. Lead acid batteries for the these are the example for galvanic cell. Okay. Here electrochemical cells are two types. Okay. Electrolytic cell, in this electrical energy is converted into chemical energy. Okay. So this in next galvanic cell, if we take galvanic cell, so this is reversible, means here chemical energy is converted into electrical energy in galvanic cells. Okay. So example is bicellular lead acid batteries. Okay. So take the screenshot for this. So next, what is cell here? Cell is a single arrangement of two electrodes. Okay, two electrodes are arranged in one cell. Okay, single arrangement. Okay, so that it is called as. Okay, what is cell here? Cell is a single arrangement. Cell is a single arrangement of two electrodes and two electrodes and electrolyte. Means electrodes are also there as well as electrolyte also there. Okay. So in this cell, okay, I'll give. Okay. Okay. So cell is this is the board. Okay, ma. I will try to write. Okay, maximum. But because this is a physical, so many derivations are there, na. Okay. Neatly means this is the cursive writing, so I am nakide alavatu. Okay. So please understand. Okay. అర్థమైందా? నేను I cannot write that normal writing. Okay. So నాకు ఇదే అలవాటు. So that's why I will write in this manner. Please try to understand. So I write clearly only na. Okay. 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 For you only problem I think. So what about others? Hmm? Okay. మాక్సిమం అర్థమవుతుంది అమ్మా, ప్రతిదీ అర్థమవుతుంది. నేను మరి అంత ఖర్చు రైటింగ్ రాసినా కూడా అర్థమవుతుంది మీకు ఈచ్ అండ్ ఎవ్రీ లెటర్. ఓకే. స్క్రీన్ షాట్ తీసుకుంటే యూ కెన్ వెరిఫై అగైన్, రైట్? ఓకే. Cell is a single arrangement of two electrodes and electrolyte. Okay. Next here. So what is battery? What is battery? Battery consists of two or more cells. Okay, two or more cells arranged in a series or parallel. Okay, battery consists of consists of two or more cells arranged in a or series. Okay, that's it. In a series. Okay, so next, so let's see what is this one. Okay, here we'll have electrodes. This is zinc rod. Okay, zinc rod. This is tabulation. The red color, which is a aqueous zinc sulfate. Okay, and here blue color one. This is a copper rod, and this is a aqueous copper sulfate. Aqueous copper sulfate. Okay, so this is the porous diaphragm which separates two solutions. Okay, which separates two solutions. So this is the battery. Okay, here it consists of two or more cells. Okay, here zinc rod will be there and copper rod will be there. Aqueous zinc sulfate and aqueous copper sulfate will be there, right? So at zinc rod, so it acts as a anode. Okay, it acts as a anode. And what about the copper? It acts as a cathode. Means here in anode, at anode oxidation takes place, oxidation, and here at cathode reduction takes place. Okay, reduction takes place. Let's see the cell. How we have to arrange the cell. Okay. The whole cell. Okay. So here we have zinc. Okay, zinc. Next, what happened? It last electrons, okay, and becomes 2 plus, okay. If zinc is a, it is what is the oxidation state here? 0, okay. So this is a elemental form. So in element, if you take any element, if this is elemental form, what is the oxidation state of elemental form? 0, okay. So here no loss of electrons, but here what happened here? It lost 2 electrons, and it is converted into 2 plus, okay. 2 plus means which process happened here? Oxidation, okay. Oxidation, okay now. So next, so copper, what it will take actually? This 2 plus, it will accepts 2 electrons, and it becomes copper, okay. Copper, okay. Actually this is in oxidation state already. Copper 2 plus accepts 2 electrons, okay. 2 electrons, and becomes a copper, okay. So this process is called as reduction, okay. Reduction, okay. So here zinc lost electrons, and these 2 electrons are transferred to this copper rod. This copper rod which accepts the electrons, and the process accepting of electrons are called as reduction, okay. Reduction, okay. So let's see what is the net reaction. Is it completed? Okay, okay. So here we have to take the net reaction, okay. So what is the net reaction here? We'll have zinc, okay, plus copper 2 plus, okay. And in this zinc lost electrons and converted into zinc 2 plus, and at the same time copper 2 plus accepts electrons, and it becomes copper, okay. Copper, this is spontaneous reaction. This is spontaneous reaction. Spontaneous reaction, okay. For this we have to represent cell. Zinc will be there. What is this here? This is anode, and we have zinc sulfate, okay. So this lost it electrons, zinc 2 plus plus sulfate, okay. So next, here we have copper sulfate, and we have copper, okay. So E cell is equal to positive. Cell is equal to positive. So what are the conditions for spontaneous reactions? Delta G is equal to negative, delta H is equal to negative, and what about here? Entropy. Change in entropy is positive. Okay. So let's see what are the changes. What are the conditions for spontaneous reactions for this one? Okay. Okay, write down for this. Delta G is equal to negative, as well as delta H is also negative, and delta S is a positive. Okay, for spontaneous reactions. So spontaneous reactions, what are the free energy? Negative, enthalpy also negative, and entropy, change in entropy is a positive. Okay, and here zinc, copper, 2 plus zinc becomes copper. Here E cell is a negative. Okay, means here this is non-spontaneous reaction. Okay, if this is a spontaneous reaction, so let's see the non-spontaneous reaction. Non-spontaneous reaction. Okay, so next reaction condition. Here E cell is negative. At that time, delta G becomes positive, delta H becomes positive, delta S becomes negative. Okay, okay. Let's see what is electromotive force. Is it completed? Electromotive force. Electromotive force, which is nothing but EMF. Okay, EMF. Here a potential difference will be there. Okay, a potential difference will be there which causes electricity flow from one higher electrode to lower electrode. So how the electricity passes through from higher electrode to lower electrode? So the difference between the this is potential energy is measured in volts. Okay, so that is measured in volts, and we can write it as the force which which causes which causes the flow of electrons, which causes the flow of electrons from higher electrode to lower electrode. Okay, which causes the flow of electrons from one electrode to another electrode another electrode. By this, what happened? This results in the flow of current in the flow of current is EMF. The flow of current is EMF. Okay, EMF. So this is measured in EMF, measured in, or you can write it as small letters also. EMF. Okay, EMF. This is measured in volts. Measured in volts. Okay, measured in volts. Or some other definitions are there. The difference of the difference of the difference of potential which causes the difference of potential which causes current to flow from the electrode of higher potential higher potential from the electrode of higher potential to that of lower potential. Lower potential is EMF. Is EMF. Okay. So here the force which causes. Okay, we can measure it as a force. The flow of electrons from one electrode to another electrode. So the flow of current is nothing but EMF measured in volts. So what are the units here? Volts for this EMF. What are the units, ma? Units for this one, volts. Okay, or we can say it as the difference of potential which causes current to flow from the electrode of higher potential to that of lower potential is EMF. Okay, lower potential is EMF. Another definition also there. Okay, the potential difference which causes electricity from higher electrode to lower electrode. Here we have mentioned this electrode of higher potential, or otherwise we can write higher electrode to lower electrode also. Okay, so that's it. That is the EMF. EMF. Okay. Here galvanic cell anode is negative polarity. Okay, is it completed? Okay. So here we know that galvanic cell. Okay. In galvanic cell. So anode is a negative polarity. Okay. Anode is a anode is negative polarity. Negative polarity because of electrons flow from its to cathode. Okay. Because here in this galvanic cell, electrons are flow from electrons flow from this anode to cathode. Okay, because of electrons electrons flow from its to cathode. Next, what about cathode? Vice versa, reverse. Cathode is a positive polarity. Cathode is a positive polarity. Positive polarity because of the electrons flow from cathode to anode. Okay, here because of electrons electrons flow. Okay, flow electrons flow from this to this. Okay, same. Okay, anode to cathode, right? So here cathode to anode, vice versa. Now let's simply write this enough. Okay, positive polarity, negative polarity. Okay. Next, single electrode potential. Single electrode potential. Single electrode potential. So what is single electrode potential means here the tendency of electrode gains or lose electrons when it is contact with own ions. When it is contact with own ions is called as single electrode potential. Okay, here the tendency of an electrode the tendency of an electrode to lose or gain electrons when it is when it is contact with own ions in solution is called is single electrode potential. Only here one electrode act as cathode as well as anode. So that's why it is called as single electrode potential. Single electrode potential. There are no another electrode. Okay. So here both gaining or losing means oxidation and reduction takes place within that solution. Okay. So within one electrode. So that is called as single electrode potential. Single electrode potential means here what? This electrode to lose or gain electrons. Okay, with the when it is contact with own ions is called as single electrode potential. Okay, or we can write means here the tendency of losing electrons means it gets oxidized. Okay, it is called as oxidation potential. If it is gains, if tendency of gaining of electrons is called as reduction. Okay, reduction means reduction potential is present. Both oxidation and reduction takes place at the same electrode. Okay, standard electrode potential. So these are all the basics. From tomorrow onwards, I will start a main topic. Okay, but you have to know what are the basics. No, so that's why I have explained you these basics. I will give you notes. Okay, most probably 2 to 3 days. Okay, because okay, I will try to give you. Tomorrow also you'll have class. Okay, I will tell you what is the time of the class. ఓకే ఇస్తాను మీకు నోట్స్ కాకపోతే నేను ఊరు వెళ్తున్నాను చూసి ఇస్తాను ఓకే ఐ విల్ గివ్ యూ మోస్ట్ ప్రాబబ్లీ బై టుమారో ఆర్ డే ఆఫ్టర్ టుమారో ఓకే ఓకే ఐ వాంట్ టు స్టాప్ ద క్లాస్ నౌ ఐ విల్ కంటిన్యూ టుమారో థ్యాంక్ యూ టు ఆల్